Okay, so in this lesson we are going to look at functions. So for example, what are functions? We're going to look at what is the domain of a function and then what is the range of a function as well. So let's try and understand exactly what functions are. So imagine if scientists in Ireland, they wanted to carry out a study and they wanted to understand, for example, how many Garth Brooks fans will there be in the country if we keep letting Garth Brooks, for example, play in the country. So we have these two factors, if you like. So we have, for example, the growing fan base or the number of fans, and then we have the number of concerts, for example, that Garth Brooks would play. And we can represent these using two variables. So, for example, the number of fans could be represented by the variable f, or the number of concerts he played could be represented by the number c. And scientists could go away and they could come up with this mathematical formula to represent, for example, this growing number of Garth Brooks fans in Ireland. Now, we don't have to use the letter F or the letter C. We can use any letter. So you could as easily represent the number of fans by the variable X, and you could represent the number of concerts by the variable Y, or you could represent it the other way around either. So what we can do then is we can come up with a mathematical expression that looks something like this. So F, so the number of fans, is going to be equal to C squared, which is the concert, minus 2 times C plus 3. And what we can do then is we can work out, so for example, we can work out the number of concerts that he plays. So another way to represent this is basically a function. So when we put in one thing, we get out another thing. So for example, when we put in the number of concerts that Garth Brooks plays, it'll give us out F, or the number of fans that he's likely to have as a result of the number of concerts that he plays. So for example, if he was to play, let's say, 10 concerts in Ireland, and what we can do is we can call this, so this is function, let's say C, so it's like this function C. So basically the input is C, and then the output is going to be F. Okay, so the number of fans. So for example, if he was to play 10 concerts, then we could put this number in. Wherever there's a C, we can substitute in the value of 10. So that would be 10 squared minus 2 times 10 plus 3. And then what we can do is we can use our rules of algebra and we can work this out. So 10 squared is going to be 100 minus 20 plus 3. And then if we add all this up, so 100 minus 20 is going to be 80 plus 3 is going to be 83. So the function tells us that if Garth Brooks plays 10 concerts in Ireland, he will gain, let's say, 83 new followers. So this is an example of what we call a function. So we're taking an algebra expression and we're using it to represent this thing that we call a function. So this is just like a simple example of it. But there's many different functions that describe many different phenomena, for example, in nature. And we can use these mathematical formulas to represent many different things. So if we take then, this is basically what a function is. So this is like an example of a function. So when we take, so what is the domain of a function? So the domain of a function is basically the inputs, if you like. So for example, the inputs that we put into the function. So for example, the domain in this example would be C, would be the number of concerts. So again, we can put in many different values. So we could put in 20 and then see what we get out. We could put in, if he plays 30 concerts and then see what he gets out. And we could put in, so these would all represent what's called the domain. So it's like the input. The range then is what we get out. So when we put in the function, so the range, for example, would be the number of fans. Okay, so for example, 83 is part of the range. But if we put in a number of domain values, okay, we change these domain values, we get out a number of range values. So it's the value that you get out. So let's look at some more examples of functions. So here we have, so this here is a simple function. So sometimes the functions are represented like this. So yx. So y is equal to 3x squared plus 4x plus 2. So this is a function, and the domain is going to be x. It's what we put into the function, and then the output is going to be function x, or what's called y, the y value. So for example, we could let x, so you basically, the way to kind of think about it is you have the domain, so the domain is like the input, and then the output then is what's called the range. So you put in one thing, so you can think about it like a box. You put in x, there's a function that's carried out on x, okay, and then you get out y, or function x. So as an example, if I was to say, imagine if we were to let the input x be equal to 3, okay, so it tells us that, so x is equal to 3. So what's going to be done to this value of 3? Well, we're going to go 3 bracket 3 to be squared plus 4 times 3 plus 3. Okay, so this is going to be the process, or the function, how the function is going to work on this input. So that would be 3 times 9 plus 12 plus 3, and then 3 times 9, 9 and 9 is 18, and 9 is 27, plus 12 plus 3, and that's going to give us 30. So that's going to give us, so 27 and 3 is 30, and then 12 is 42. So the output then, or function x, y, is going to be equal to 42. So basically, when we input the value 3 into this function, the function gives us back 42. So when x is equal to 3, y, or function x, is equal to 42. So it's like an input or a process that happens. Similarly here, so we have a function as well. So we're calling this gx. Okay, so x is like the input or the range, and then gx is the output. So, and we can even represent it like this. So g, okay, or the output, is equal to x plus 4. So again, we can think about it like this. So we have our domain. And then we have our range. So we could have a number of different values. So imagine if we, let's say we let, so these are going to be our x values. And then these are going to be our gx values, or function x values. So if I put in 1, it's going to give me 1 plus 4. So gx is going to be equal to 5. If I put in 2, it's going to be 2 plus 4. So gx is going to be 6. If I put in 3, for example, then it's going to be 3 plus 4, which is equal to 7. And so and I can just keep putting in, so these are our domains, and then this is the range of values that you can get. So that's basically like what a function is, and what the domain of a function is, and then what the range of a function is. Then sometimes what they do is they give you this kind of a graph here like this. So this is just a simple function graph, and they'll ask you the question, is this a function, or is it not a function? So for example, when you get the graph that looks like this, on the left hand side you have the domain, or the inputs, and then on the right hand side you have the outputs, or the range. So for example, when I put in 1, I get out 1. When I put in 2, I get out 3. When I put in 3, I get out 5. Okay, so 2 times 1 So I put in 1, so it's going to be 2 times 1 minus 1 will give me 2. If I put in 2 as the input, it's going to be 2 times 2 minus 1, which is 3. If I put in 3 as the input, it's going to be 2 times 3, which is, so 2 times 3, which is 6 minus 1, which is going to give me 5. So what we can say is that, so with a function, like one input will give us one output. Okay, so one input, if you like, is mapped to one output. In that way, what we can say then is that this guy here, based on this graph, is a function. So this is a function. Why? Because each x value, okay, gives us one y value or one range value. So it's linked to one value. So if we look at something like this, so is this a function? So what we have, so when we put in 1, we get out 1. Okay, so far so good. When we put in 2, we get out 3. Okay, so that's fine. When I put in 3, I get out 3. That's okay, and that's allowed. So for example, 2 different input values can give you the same range value, and that's okay. Now the problem with this is that this is not a function because we have one input value, and that one input value can give us 2 output values. So for example, when we put in 3, it can give us 3 or it can give us 6. So when you get something that's like this, where you have a domain value that gives you 2 range values, then this is not a function. Okay, it's perfectly fine for 2 different domain values to give you the same range value, but when you have one domain value that's given you 2 different range values, then it's not a function. Okay. So, and again, as I say, when we look at these diagrams, on the left-hand side you have the domain values, on the right-hand side you have the range values, and then these arrows are just mapping the domain values to the range values. So the last piece then that I just want to talk about is this, what's called the notation of functions. So it's very important that you become comfortable with this, what's called the notation of functions. So functions can exist in many different forms, but they all mean the same thing. So for example, it can be written like this. So this is function x is equal to 2x plus 4. Okay, so that's a function. So this is your input, and then this is going to be your output. It can be written like this, function with these two colons, function x is 2x plus 4. Again, it means the same thing. It can be just written like this, y is equal to 2x plus 4. Again, that's a function. It can be written like this. It could be, instead of using the letter f, they can use a different letter like g. So this is function g is equal to 2x plus 4. Again, they could use x is equal to 2x plus 4, or you could even use 2 completely different letters. For example, g times t is equal to 2t squared plus h plus 4. Let's say that would be 4t plus 3. So this is what's called scientific notation. So these functions, they can show up like this in many different ways. So it's important that you recognize when you're given something like this, that you recognize, okay, this is a function, and I know how to identify that, and I know how to identify the parts of the function. Okay, so that is like an introduction to functions. So what is a function? So thank you for listening.